Okay, so now let's look at subtraction strategies. And again, I'm going to draw a visual model at the same time, which again is another strategy all by itself. So I'm going to just keep these whole numbers. So I have what, 12 and a half minus 2 and 5/6. Again, anytime you add or subtract, you need a common unit, right? You can't take 12 inches minus 2 centimeters. It doesn't work. So again, fractions are just units. So I'm going to scale up, and I'll talk about what that is in the picture in just a second. All right, so in my picture, remember subtraction, you only draw the first one, and I do not know why I picked 12, but okay, 1, 2, 5, 6, 7, 8, 9, 10, 11, 12. That was not a good choice. All right, so pretend these are all shaded in here. And again, pretend they're all the same size because I wasn't very consistent there. So remember, you have 12 and a half, and then you're trying to take away this many. All right, so in base 6, I have, because again, they cut their pizzas in 6, right? So when I get that common denominator, that represents cutting this, what used to be 2, or cut in half and one really big piece. I'm going to cut it in thirds, which it takes 2 cuts to make 3 things. So you can see how each big slice now is worth 3. So you can see my 1, 2, 3 out of 6. Okay. All right. So I want to take 5 slices away, and I only have 1, 2, 3. All right. So what do? Well, I ungroup a pizza, and pizzas at this pizza place are cut into 6 because that's what your unit is. And again, that's all shaded in. All right. So when you ungroup a pizza, I only have 11 left, right? There's 10, 11 left. And when I ungroup this pizza, like I open up the pizza box, there's 6 slices in there, but there's also 3 old ones. So that's why I get 6, 7, 8, 9. Because in base 6, when you ungroup a whole, you get 6, and then you had 3 slices already there. So the 6 new ones, the 3 old ones make 9. So then 9 minus 5 is 4. And then 11 minus 2 is 9. All right, so let's look at that. So now that I have 9 slices, I'm going to take 5 of them away. All right, so I'm going to take, let's see, these 3 and those. Okay, those are all going away. And then I'm going to take what, 2 full pizzas away? So those are going away. Okay, and so when they go away, what's left? 1, 2, 3, 4, 5, 6, 7, 8, 9 whole pizzas. That's there. And then how many slices are left? 1, 2, 3, 4 slices out of 6. So again, this is doing it with mixed numbers, but I'm also mimicking. This is another method doing it with a picture. And then I am going to simplify this to 2/3, divide by 2, divide by 2. And again, what that kind of represents is that, let me see if I can find a colored pencil here, is that say I decide I have 4 individual pieces, I could decide to group these, you know, kind of like 2 at a time maybe. And so I can either package them 4 separate slices, or if I kind of mush 2 together and 2 together, it'd be like 2 out of thirds or 2/3. All right. The other one is improper, which is converting everything to slices. And again, sometimes kids like this because they don't like the fact that all these numbers in front are kind of base 10, but then when you go into this column, you're in base 6. They don't always like that. So they'd rather just be all slices. They don't like messing with pizzas and slices, just like, let's all be slices. All right, so I'm going to do this. So let's see, this would be 12. Again, I don't know why I picked 12, but I'm going to have to live with it. 5, 1, 2, 3, 4, 5, and then 12 and a half. Okay, so again, shading is going to represent I have it. So I have 12 and then I have half. Okay, so I'm going to make this improper. 24 plus 1 is 25 halves minus, and this is what? 2 times 6, 12, what, 17, 6, is that right? So 12, okay, I think that's right. Now, that represents me cutting all these in half, because if I have 12 things and I cut them all in half, that's why you multiply by 2, because you'd have 24 things. So that's why the 12 times 2 comes in. 12 things that have 2 units each would be 24, plus the one I already have is 25. All right, now I need my common denominator. So times 3 times 3, 75, and this is where I made a really bad number choice. All right, so now I have to cut all of these into 3s, which again, 2 cuts per piece make 3. 1, 2, 1, 2, 1, 2. Yeah, this was not a good choice, but oh well. I will live with my decision. because it's too late now. I'm not going to make a new video, so we are just going to deal with it. Whew, okay. All right, so again, if you take, you should be able to count 75, 6 there. And remember, the second number is what you take away. So my picture is only, you know, this part. All right, so now I'm going to subtract. And again, if you need to do some scratch work, you can do scratch work, or you can add on all those strategies we used earlier in life. You could add on. So like if you're like, ooh, 17 and 8 make 25, and then I need another 50, great. All right, so this is all slices of pizza. This is saying that if you have 75 slices of pizza, you take away 17 slices, you just have 58 left. The problem is now you have to repackage it all. So you have 58 slices of pizza and you want to do groups of 6 because that's, you put 6 slices in a pizza box. 6 times 10 is too many, that's 60, so we're going to do 9. So what that represents is like whatever's left here, you would have, let me find some space. You would put 9 in pizza boxes. Or I'm sorry, 9 pizza boxes, and in those would go, what, 6 slices. So pretend I have 6 here, 6 here, 6 here, 6 here, 6 here. And again, you're just shoving them in the shape of a circle pizza. All right, so that would use up 9 groups of 6 is 54, right? So I use up 54, and then I would have 4 left, so that would be 4 slices left. So my answer, 6 goes in 58, I would have 9 whole pizza boxes. And I would have, did I draw the right number left over? Yeah, 4 slices left over, and my unit is 6. And then again, I could simplify that, divide by 2, and 2/3. And that would be like if I kind of, I don't know, somehow glued these together and glued those together, you know, into a bigger, a double unit, like into thirds. But all right, now, so that's another method. All right, so let's look at some of kind of the adding and subtracting strategies we did in 114. So minus 2, 5, 6, which are probably better with that bigger choice I made there. Let's see, we could do adding on. Okay, so if you think of, I'm at 2 and 5, 6, and I want to go up to 12 and a half. So I could add on, what, a 6th would get me up to a whole number of 3, which is nice. And then, what, another 9 would get me up to 12, which is nice, and then another half. So those are all kind of good. So I have 9, and then a half, and then a 6 that I need to add up. Common denominator, because again, fractions are all about units. They're like inches and centimeters. That's all they are. So then I get 9 and 4, 6, which is 9 2/3. Scale down, simplify. So that's one way. Probably my favorite way is doing that kind of that decomposing with the 1 trick. I really love that. I think it's super smart. So making this 11, and then instead of making this a 1, make it whatever fraction you need that equals 1, and I need the denominator to be 6 to deal with the subtraction. So I'm going to do 6, 6. And then I have my half. And again, these are all positives because you have these. And then over here, this is all subtraction. So again, I'm taking away 2, but I'm also taking away 2 and 5, 6. So I'm taking away the 5, 6 part as well. And so then you have some nice math here. So let's see, 11 minus 2 is friendly. That's 9. Ooh, 6, 6 minus 5, 6 is super friendly. That's 1/6. And then I still have that half in there. So again, scale up, scale up. So get your common unit here. And then you have 1/6. Plus 3, 6, so that's 9 and 4, 6, which is 9 2/3. Let's see. I mean, there's tons of method you could do. I don't know that I want to shift both. I'm not sure that's super helpful. So those are probably the main ones that I think are probably the best on subtraction. But again, oh, one other thing I was going to say, and I'm not going to do it with this problem because yeah, I made a bad choice. So I'm going to do it with, say, something like this instead. Similar, but a little better numbers. Is have 6 and thirds work really great with our pattern blocks. So 8s don't. But so this could be that I have 3 hexagons. And a half would be a trapezoid. Right? So remember these guys, right? Like I'd have, 1, 2, 3 of those. And then a red trapezoid would be half. And I want to take away 1 and 5, 6, which really means I want to take away what? I want to take away 1 trapezoid, or no, 1 hexagon, sorry. I want to take away one hexagon because that's our whole, right? We said one hexagon was our whole. And then I want to take away 5 triangles, right? Because it takes 6 triangles, right? Like 6 triangles to cover up or to have the same area. Remember, this is an area model. And again, subtraction, you only draw the first problem. So I have this and I want to take away this. And again, I can kind of mimic both methods that we did earlier. So as far as with the whole number or the mixed number part, your common denominator would be this times 3 times 3. Again, why do you multiply by 3? Because there are 3 triangles in a trapezoid. So when you switch units, you're saying, ooh, there's 3 triangle per one. And so you're changing how many you have and then the unit. Minus 1 and 5, 6. And again, you can't subtract these because you want to take away 5. So again, what do? You ungroup just one of them into triangles. So now you have 2 left, but when you ungroup, you're not in base 10. You get 6 of these. So you get 6 and you have 3. So 6, 7, 8, 9. That's where that 9 comes from. Now, can I take away 5 of them? Yeah, so I'm going to take away these 5. Those are all going away. So when I do that, there's 4 left. You can see them, 1, 2, 3, 4. And then when I take a trapezoid away, or why do I keep saying that? I am so sorry. Take a hexagon away, there's 1 left. And again, I can do that same problem with all triangles. So I have 3.5 minus 1 and 5, 6. Again, I have my hexagons. Hexagon, hexagon, hexagon are my whole. Oh my. I can tell it's towards the end of the week. All right, so I have all my hexagons. I want to take away this. So in this method, I'm going to go 3 times 2 is 6 plus 1 is 7 halves. What that would be is me changing them all into trapezoids, right? And then 1 times 6 is 6. I want to take away 11 triangles. So I have this. Now I need to get triangles so that I can take away triangles. So I'm just going to replace all these with green triangles. So again, I would trade them out. I would, get rid of the yellows and do this. And so now that would represent me putting 3 triangles on top of the trapezoids and 3 triangles down here on top of the trapezoid because I had 2 red trapezoids and each one is worth 3. So I should get 21, 6. So let's see, 6 times 3 is 18, 19, 20, 21. You can see that. And now I have everything converted into triangles. So there's not like I have some hexagons and I have some triangles. I just have one shape. That's the beauty about doing improper fractions. I have all triangles. So again, can I take away 11? Yeah. So let's see, there's 6 and let's see, 6 and let's see, 7, 8, 9, 10, 11. All right. Those are all going away because I wanted to take away 11. So then what's left? Well, there's 6, 7, 8, 9, 10. And the unit is 6s, which means the unit is triangle. That basically means you have 10 triangles. I mean, this is how many you have. This is your unit. All right, so I have 10, 6, which again, divide by 2, I could get 5/3, which means that my answer is 5 rhombi. And so again, I might have to mush these together, but like there's a rhombi here, there's 1 rhombi. These are the blue ones. There's another rhombi here. Third rhombi there. Those are all together. So rhombi here, rhombi here, rhombi here. I can get another rhombi right there. And then these 2 together, if I mush them together, I could get a rhombus. So again, you can see that I could have 1 rhombus, 2, 3, 4, 5 rhombi, which again, that's what this unit means. So when I simplify, it represents me switching from my 10 triangles, which are 10, it takes 6, to 5 rhombi, which takes 3. And again, I divide by 2 because there's 2 triangles per rhombi. So that's just that conversion. All right, hopefully that helps on subtraction of fractions and gives you some things to think about.